Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. In the last episode, what we covered was serialization with Gson. So in this tutorial, of course, we're going to cover deserialization with Gson. That is, we are going to cover how to load text files into our game and convert them to Java objects that are immediately usable within our game. So this will also help out if you're just looking how to use Gson to deserialize abstract data types, because that is the big problem that we are going to run into in this tutorial. We are also going to look at how to create custom deserializers and serializers with Gson to cover this problem. So before we begin coding, let's take a look at the problem in more detail to get a visualization of what exactly we are going to be solving. Alright guys, so the way that Gson works is it uses the class to determine how to deserialize an object. But if you remember, our game object consists of a bag of components, which are this abstract class, which could be one of anything. Any type of functionality you want to implement would be a component. That poses a problem for Gson. How do you know how to deserialize an abstract class, right? Because what we say is, hey, we have a bunch of components, please deserialize this. Then it gets to a rigid body. How does it know it's a rigid body? It can't infer that because currently it's just serializing it as a component. So what we have to do is we have to do a little custom serializer and deserializer for components, because we're like, hey, we need to embed a little bit more information, and it's actually pretty straightforward. It's just like you would expect. We need to say, when you serialize a component, make sure to serialize its type, and we will record that. So if it is a type of rigid body, we will know that. Then we will deserialize it according to whatever that type was. So then when we go to deserialize, we will say, hey, we have a special method that says, look at exactly what type this was, and we will infer this to determine what type we should deserialize it as. Now, this does pose a little bit of another problem, because with Java, you have to have your type names fully classified. So if this is in some sort of package, you would have to list out the entire package name. So it would be like org.commons, whatever, all the way till you get to your components package. And you must make sure that these are all in the same package. If they're not, you're going to run into an error, because then all of a sudden it has no idea what type this is. It needs the fully classified name. That stuff is all fairly straightforward though, right? That's not too much of a big deal. But there was one other thing that we have. So you have game object, you have component. Game object has a list of components. Component has a reference to game object. What do we do about this? So remember, we ran into that Stack Overflow error. It's because when you go to deserialize this, it finds this, then he says, oh, I got to deserialize this, and then it keeps going back and forth forever. So what we did was we marked this as transient, but now what that's saying is just don't even mention whatever this is. But that's not entirely true. We do need this reference. This reference is important, right? So what we can do instead is we leave game object mark as transient. But when we are deserializing a game object, what we will do is we will say, hey, go ahead and deserialize every single component. So then we get a list of components. And as we are deserializing these, let's actually add them to our game object. So instead of leaving the onus on the serializer to figure out how to serialize both of these, we just say, okay, serialize game object. Well, we know we're going to get a list of components with that. Then when we go to deserialize, we go, hey, as we're getting these components, let's add them to the game object, and we gain this circular dependency once again, but we don't run into any Stack Overflow errors because we are doing it once, because we know it only needs to be done once. So this is how we're going to solve these two problems. Just keep it in mind as we're coding, because it is fairly straightforward, but it always helps to have a visualization of what exactly we're doing. So let's actually code this and see how it works. If we take a look at Gson's user guide, we can actually find exactly what we need here. So this is just in case you wanted to try and do this yourself and you're like, how in the world do you even find out about this stuff? Well, look at this. If we check out their user guide, it says custom serialization and deserialization. And then it goes ahead and gives us extensive examples of how to write our own serializers and our own deserializers. And notice these two things. It implements this JSON deserializer, and this implements the JSON serializer with the type of the type you are trying to serialize or deserialize. And then you get a few variables. You get the object in the case of serialization and some other stuff, and then you get the context in the JSON in terms of deserialization. So those are the important things to note about this. Of course, if you have other problems, you can look at other solutions, which I did. So I had a specific problem. I tried to find a better solution than that, and I found it. Now, let's go ahead. We are just going to implement this serialization and deserialization right in here. Probably it would be better in a different class, but for now, this is fine. So what we're going to do is we're going to call this our component deserializer, and this will actually serialize too, but it's fine. And so we're going to say, hey, this implements, and let's take a look at this thing again, the JSON serializer and JSON deserializer. So we're implementing both of these. So we'll say JSON serializer, and we'll give it the component type. And then we'll say it also implements JSON deserializer, the component type. And let's actually just move this to a new line so that we can see all that. Now, if we implement those methods, just hit Alt-Enter to get that to pop up, we get all this stuff. So these are the exact function signatures that we just took a look at. And you'll notice this one throws a JSON parse exception. So this one could actually return a parsing error, which is fine. Now, how do we actually go about doing this? Remember, we said we need to embed the type information when we're serializing. So let's actually serialize first so that we can see how we could do that. What we can do is we can say JSON object result equals a new JSON object. And this is very similar to what Google is doing. Remember, we can look at theirs. They basically say return a new JSON primitive with whatever they're trying to do. We're returning a new JSON object because we have not a primitive, but an object. Then we can say result.add, and we'll say type. This is going to be what type are we dealing with. Then we know this is just going to be a JSON primitive, and we are literally just going to embed the type name as a string. So we'll say new JSON primitive, and we're going to say source, which is the component we're serializing, .get class, .get simple name. You could actually change this to get canonical name, which would reduce the need for having to know the package path, which actually might be a better idea. I think I might do that. So let's see what this is doing too. Right now I'm going to say print line, or actually we'll just print it after we serialize it, see what happens. So we're going to add the type, and then we're going to say we also need the properties, right? And we don't want to write custom things for that because Gson already does all that stuff. So we can just let Gson do all the work for us. We'll say result.add properties. And then we're just going to say context, which is our serialization context, .serialize, source, and then we are going to give it the specific class. So we will say source.getClass. That will serialize the rest of the stuff, and then we can return our result. Now we have what normally would have been serialized, and we have a type, which tells us what type of class we're dealing with. Let's see what actually happens here. Let's go back into our level editor scene, and remember right here, we were serializing stuff and we tried to deserialize it, which didn't work, still won't work because we haven't quite finished that part yet. Now, in order to get it to use our custom component deserializer, we have to tell Gson, hey, we're using something special here. And let's see if they actually talk about this too. Yep, so they talk about it right here, right before they do it. And you have to register a type adapter, which basically says, hey, for this class, use this serializer or deserializer, which is exactly what we're doing. So we'll just say inside of this builder, we'll say .register type adapter, and we are registering it for component.class. And the type adapter we want is a new component deserializer. And that will register this to deserialize and serialize our components. And let's go back to level editor scene. Let's just see what happens now. So if we run this, should have serialized game object, and if we take a look inside of our components, we notice it says type components.sprite render, then it goes into the properties. This is perfect. Now we have our type, right? And let's see if that is the fully qualified class path. That is. So you'll notice it goes all the way down, so we don't even have to worry about what the entire class path is because we're just going to use that. So now that we have the type and the properties, we want to do the opposite, which is to deserialize this stuff. So how do we actually deserialize that? Well, it's very similar. So we want to get our JSON object back. We'll say JSON object equals JSON.get as JSON object. So this is the JSON that was passed in. We're just getting this object that we created back. So we know it's going to have a type and it's going to have a properties. We want to take advantage of that. So we'll say string type equals JSON object.get type, right? It's going to be a type. And then we're going to get it as a string because that is what it is. Then we're going to say JSON element equals JSON object.get properties. This is going to be all of our properties. Next, we want to try and return a deserialized specific component. And so we're going to have to do a try catch because there is an exception that could happen, which is the class not found exception. So we'll say if that happens, we're going to throw a new exception, a new JSON parse exception, because that is the exception we're allowed to throw. And we're going to say unknown element type, and then we're going to say plus type, and we're also going to give it the complete error. And I had a typo there. So we basically throw a JSON parse exception. We don't know what type this is, and we give it the type that we tried to get, which is here, and we give it the rest of the error, which is passed in to that class not found exception. Now, what are we trying to do? We're trying to deserialize a specific class. So what we'll say is return context.deserialize, because we don't want to do this work, element, and we want to do a class dot for name, and we just want to pass it that type. So what this does is it basically says, hey, in this case, we have a components.sprite render, and it's basically saying, like we did in here, we want to do JSON.deserialize or from JSON, and then it's saying take the serialized string, and we are doing a sprite render.class. That is all that's happening inside here. We are just doing it a little bit manually because we have to get the type ourselves, and it uses these properties. See, we're saying the element, which is that JSON string, and we are just letting JSON do the work for us. So that's really cool. Let's see how that works out for us. And it's actually still not going to work out correctly because we haven't finished the game object part. So yeah, let's get the game object part done first, and then we'll get the rest of this done. So game object deserializer, we have to do something similar for our component deserializer. We'll go and create a new Java class, say game object deserializer. I guess we should probably call these type adapters, but it's fine. This is going to implement the JSON deserializer, and it's going to take in a game object. We are not implementing the serializer for this because serialization works fine for us. And we get the same method signature. And we also notice this throws the JSON parse exception as well, just in case. So how do we deserialize it? Remember what I said, we basically just have to add the components to the game object as it gets deserialized. So we'll say JSON object equals JSON.get as JSON object. So just like we did. Then we know the string name is going to be JSON object.get name.get as string. How do I know this? Well, JSON is going into our game object, and it's just getting all these properties. So we know we're going to have a name. We know we're going to have a property called component, transform, and z-index. Those are the properties we will get. That's guaranteed. So we're getting those right in here. Now, how do we get that list of components? Well, we can get that as a JSON array. We're going to say is components equals JSON object.get as JSON array, and then we're just going to give it the components name because that was the name of the variable. Then transform equals, and we're going to say context.deserialize JSON object.get, and we know this is called transform, and we're going to say using the transform.class. So that's just like our JSON.fromJSON, except we're saying use this variable name, and that's going to get us the correct JSON, and then we're going to deserialize it to a transform class. Int z-index, very similar, context.deserialize JSON object.get, and we're going to say z-index, and we're just going to give it int.class. Okay, we have everything now, so we can actually construct the game object. We'll say game object equals a new game object, and we can actually pass in the name, the transform, and the z index since we have all those. So we'll say name, transform, and z index, which is also why we don't actually have to worry about making sure this is constructorless, because we're doing this ourselves. Then we can say for JSON element E in components. JSON array is just an array of elements, and if you remember from our component deserializer, we can literally just do the element and then its class name. But in this case, we don't know what class it is, right? Because this is just a list of components. So what we can say is component C equals context dot deserialize E, and we're going to get component.class. So what's going to happen here is the component's going to get deserialized using our custom deserializer, which will deserialize it to the correct subclass, pass it back to here as a generic component, and then we can say go.add component C, which adds the component to our game object, giving us that circular dependency, solving all of our problems. Then we will just return that game object go. So this should solve the rest of our problems. Let's go into here, and we will say, hey, we now want to actually print out what the game object was. So we run it, we get no errors, and we get some random Java address with a j.game object, which means it serialized it correctly, and it serialized it according to all this data. So now we have serialization and deserialization. You may be asking, how the heck do we use this? Like, what good is this anyways? And let's actually find out what good that is. And one more thing too, that probably shouldn't have worked correctly. It actually probably didn't work correctly because we're not using our custom deserializer. So let's actually add that real quick too. We'll say new game object deserializer. And then let's run this one more time, just make sure it works correctly. Okay, still works correctly. Yeah, without this, what would have happened is the game object wouldn't have had any of its components. So we don't want that. We do want to keep the components. So let's implement a saver/loader with this real quick. And just as a side note, if you remember my Geometry Dash series, this took 40 minutes for each episode on serialization, deserialization. And then I don't even remember how long the saving and loading files came. So yeah, this is great. Let's go into our scene class. I'm going to copy all this too and just remove it. We will go into our scene class and we're going to create a couple of methods. One of them, public void load. Let's paste all that in there real quick too. And I'm just going to take out these print lines. We don't actually need this. We just need the Gson object that we will be using. And one last thing. Well, we'll save that for later. So what we're going to do is we're just going to do it very simply for now. We're just going to say string in file, which is whatever file it's getting it in from. And let's actually, we'll do the export first because that will probably make this a little bit easier. So I'm going to say save exit, which basically means save a file and exit. We are going to use this Gson object. And what we're going to do is we're going to try to write a file, and we will catch an IO exception, E, just in case, and then we'll just print that stack trace. Should be good. Then we are literally just going to do a file writer, say writer equals a new file writer, and we're going to say level.txt. You can change the file format too, and actually zip it up and everything, which we might do in the future, because that's probably better. Then we're going to say writer.write gson.to JSON this.gameObjects writer.close. That is it. We are now saving our entire file with this tiny function. Okay, this is amazing. This is so much easier than what we had to do in the past. Now, deserialization, almost just as simple. And what just happened here too, we literally just wrote the file. We said, write out our game objects, which returns like this big array of game objects, and it just turns it into JSON perfectly fine, which is technically JSON, without any other hassle. That's awesome. Okay, let's go and read it back in. So we'll say try in file equals new string files.read all bytes, and we just want to read paths.get level.txt is what I called it. So this is just a very simple way to read a file into a string in Java. So we're literally just reading all the bytes. I think you could have problems with this if your files are too large. It's actually going to truncate it, which is not good. So we will look into that in the future too. But let's say if not in file dot equals empty quotations, so the in file worked. And then we're going to say game object objs equals gson.fromJSON. We're going to give it the file that we just read, and then we're going to say game object dot class. Actually, I think it's game object array dot class. So we're reading in a game object array. Then we can say for int I equals 0 until I is less than that array's length, I plus plus. We will add game object to scene, and we're going to say obj's I, which should add that game object to the scene. And then we're also going to set a flag to true. This will help us so that we don't reload levels if we don't need to. So let's go in here, say protected level loaded equals false initially, and this is a boolean. But if we load a level, then we will set this dot loaded level, or level loaded is true. This will just help us prevent us from shooting yourselves in the foot and reloading a level multiple times when you don't need to. So like we actually create a level here, but we don't want to reload that. So I'm going to keep these two lines. I'm going to say if level loaded return. Otherwise, we will actually create the level. Now, let's see what happens. So if we start this up, we get this. I'm going to change this to blue. Close it and start it back up again. Nothing's going to happen. So that was kind of anticlimactic. We still have to hook those functions up, which I forgot about. So we have the load, we have the save exit function, but we're not actually calling them. Let's go into our window class. And very simply, what we're going to do is we're going to say right before we start this loop, we're going to say current scene.load. And right after we finish the loop, we're going to say current scene.saveExit. Okay, so now we call those functions when it would be appropriate. Let's change it again. Exit. You'll notice it says an external file was added. Let's see what happens when we run it. We get a blue and a green object. So this actually worked, guys. Let's take a look inside of our folder. So if we take a look inside of our folder, we'll see we get this level.txt. And if we open this up, we get this object1, tells us the components, the fully classified type name, the properties. Then we get the transform, the z-index. We get the next object, we get its components, and everything. So you'll notice it's actually serializing them twice too. We got a copy, which that's not good because that means we're adding it. And actually, I think that's because we're actually adding this twice. Let's go into here. Okay, so that seems to have been a bug when we loaded it twice. So I just deleted the file and then redid it, and we just get two objects. Let's run this one more time. So this is a good intro to bug testing too, to make sure that you don't have any unintended bugs. You'll also notice that this is no longer the active game object. We could fix that, of course, real quick. Let's just make sure if we run this a couple more times though, that the file doesn't start growing. And it does start growing. So this is definitely a problem. We don't want to create copies of these objects. So that is something that we'll take a look at in the next tutorial. But we are saving and loading the data, which is a huge step. And we'll take a look at that bug in the next tutorial, and we will also take a look at dynamically generating some IMGUI property windows for these game objects using reflection. So that will be the topic of the next tutorial. If you guys like this, please hit like and subscribe, and I'll see you next time. Thanks.